So, you've probably seen some sci-fi movies based in space. Now, while some range from being completely fantasy to being very persuasive, they all have one common fault. It defines the laws of physics, and that is gravity. While it is true you can have gravity in space, how the spaceships are made is impossible. As you may have seen in any movie, the people on spaceships just stroll around minding their own business with gravity coming as natural. But if you've seen any video from actual space, you can clearly see that is not the point. You can see that the astronauts on the ISS are baffled with zero gravity. Now, this is not a huge issue for us on Earth now. The space station is small and can only host around 6 people, and they stay there for a couple of weeks or months, a year max. But for them, zero gravity is a problem. The first time an astronaut is in space, they can feel nauseous and normally have problems with their tummies the first weeks of space living. But then it mostly resides. But of course, the bigger problem is muscle and bone loss. On average, you can lose up to 3% of your bone mass in zero gravity a month. That's why when you see videos of astronauts coming from the ISS, they can't walk at first, but they will soon recover. But the real problem is if humans want to travel the stars and live in space, losing 3% of your bone mass is unacceptable. And we still don't know the long-term physical effects, as humans haven't spent more than a year in space. And also psychological issues can occur, as people will have to cope with living without gravity for a long time. But don't worry, there is a solution to this, and it's called artificial gravity. Now, as the name refers, artificial gravity is gravity that is artificially made. Now, to this day, we haven't yet successfully created artificial gravity, but it is possible. And how, you might ask? Well, if you ever ran around your own axis with a bucket of water, you can see that even if you tilt the bucket down, the water will not go out. How, might you ask? Well, that's because if an object is spinning around a circular path, its velocity won't follow that path, but will go just a bit down, making the object not being pushed by the path, being pushed a bit down. And that's how artificial gravity works. Of course, the strength of that gravity depends on how much distance does that object cover in a certain amount of time. And that relies on 2 factors: the length from the center of rotation and how fast it's going. If both of these factors are small, then you're not going to get much of gravity. But if they're decent or even high, you might reach 1G. As you can see on this graph, it shows how much you need per factor to reach 1G. But research has shown that you have to be at least 500 meters away from the center of rotation, and there needs to be less than 1 rotation per minute for human habitability. Now you might say, great, but when will this become reality? It's no good if it happens with my great-great-great-grandchildren. Well, there's already a project to send out a testing probe on the ISS, but it has been delayed for a couple of years. So if all turns out well, it might be in this decade. So that's all for this video. If you find this interesting, please subscribe. It will really help the channel. And goodbye.